Hello, I am Nicholas and welcome to this fourth video of the WU BBE Entrance Exam Preparation course. This is part of a video series which helps you to prepare for all quantitative concepts that are relevant for the marks part of the BBE Entrance Exam. Before we dive in, I will tell you some insights. As you know, the best way to learn mathematics is to do a lot of practice. And for that, we have provided some additional materials on our website. On top of that, of course, you can find all the examples covered in this YouTube video on there as well. I encourage you to sign up, get yourself a free account, and you can follow these videos in a more convenient way. You can try the examples in your own speed before watching the solutions in the video. This way, you have the best learning outcome. When solving the equation tasks for the BBE Entrance Exam, we try to apply the following framework. The very first step is to understand the equation and to check the domain. We want to make sure that the expression is defined. For example, no division with 0. In the next step, we have multiple approaches to manipulate the actual underlying equation. This could be cross multiplication, factoring, or the quadratic formula. We will talk about these in the later part of this video. Then we try to simplify and isolate the variable of interest, which in the most cases is x. Finally, we use the value for x we obtained in this step and put it back into the original equation and check if our solution is correct. Let's start with a very easy example in the beginning. Try it out yourself before you proceed to the solutions. If the solution is too slow for you, you can adjust the playback speed of the YouTube video. To solve this equation, we will need to apply cross multiplication. Let's try it out. First, notice that the denominators are 3 and 4. Since these numbers are constants, there are no restrictions on x from the denominators. In other words, the domain is all real numbers. As we understood the original equation and checked the domain, we need to cross multiply. Multiply the numerator on the left by the denominator on the right and vice versa. Finally, let's backcheck with our solution. We substitute x equals 4 into the original equation. This way, we obtain 4 minus 1 divided by 3 equals 4 divided by 4. Both sides simplify to 1, and therefore this expression is true. We got the correct solution. Hooray! Jumping back to the statements we had to assess, we can conclude that the domain covers all real x. As we talked before, because x is not in the denominator, we include 0 as well. This one is true. The next one is also true. As you saw, we used cross multiplication. We multiplied 3 with x and 4 with x minus 1. The final solution is x equals 4, and the last statement is false. Let's dive into the next task. This one gets a little bit more complicated. As you can see, this time we have x in the denominator of the right-hand side. First of all, we start once again with understanding the equation and checking the domain. Because in division by x is not defined, we need to exclude 0 from our domain. Therefore, the very first statement is true. In the next steps, we will once again use cross multiplication and then simplify the expression and isolate the variable x before we put it back into the original equation to check our solution. We checked the domain in the first part. We concluded that x must not equal 0 because otherwise the right-hand side is not defined. Next, we cross multiply the numerator on the left with x and the numerator on the right with 2. This way, we obtain the following expression. Expanding the expression, we get x to the power of 2 minus 4x equals 6. When moving 6 to the other side, we can form the quadratic equation like here. To solve this quadratic equation, we can use the quadratic formula. As you know from the videos before, which were covered in the video series, to use the quadratic formula, we need to assign values to the variables a, b, and c. To do so, we assign the coefficient from the quadratic term to a, the coefficient of the linear term to b, and the constant term resembles c. We use these values and plug them into the formula. This whole formula simplifies to 4 plus minus the square root of 40 divided by 2. Did you notice? We can simplify this one. It's easy to say that 4 divided by 2 equals 2. But it's not so easy to say that the square root of 40 divided by 2 yields the square root of 10. But it's quite easy to get there. Note the property that the square root of 2 to the power of 2 is the same like 2 itself. So we could also rewrite the square root of 4 like we did here. And we write this part of our equation on the right hand side, and instead of 2 square roots for both the denominator and numerator, we use one single one. Now in this case it becomes quite obvious why the square root of 40 divided by 2 simplifies to the square root of 10, right? Perfect. Now we have this expression. We note from before that the domain excludes 0. Therefore, we need to type in x equals to 2 plus minus the square root of 10 into our calculators and check that this expression doesn't get 0 in both cases. It doesn't, and therefore this one is the right solution. Before we talked about plugging the correct solution back into the original equation. In the entrance exam, if you're very short on time, you probably shouldn't do that, because you better save the time and work on additional exercises and you just hope for the best that you were correct. But if you have some time left, of course, feel free to calculate the value for x, plug it back into the original equation. Now, let's check the answer statements. As we noted in the very beginning, the domain excludes 0 to prevent the right-hand side from becoming undefined. And as we calculated just before, the correct solution is this one. Therefore, the first two statements are correct and the third one is false. Before, we manipulated our equation using cross-multiplying and the quadratic solution formula. Now, you might like to use the quadratic solution formula, but there is an even faster way than that, which is factoring. Now we will try to find the zeros of this equation using factoring. And for the last statement, we will calculate the discriminant, which requires some parts of the quadratic solution formula. Let's start. And we start by checking the domain. Because there's no division or root involved, it's easy to say that there are no restrictions in our domain. In the next step, we start by looking at the factors. As you know, that we need to find two numbers that multiply to 6 and add up to -5. You might need to play around a little bit, but then you will quickly find the factors -2 and -3. These multiply to 6 and -2 and -3 add up to -5. Therefore, these are our factors for this equation. Using these numbers, we can write the original equation in the factored form, like here. The factored form helps us to easily see the zeros for the equation. If one of these parentheses gets 0, the whole equation gets 0. And therefore, we need to use these parentheses and set them equal to 0. Now, it's very obvious that here x is equals to 2, and in the other case, x equals to 3. But sometimes it's a bit more complex. As you know, for the last statement, we need to calculate the discriminant. The discriminant is the part under the square root in the quadratic solution formula. To calculate the discriminant, we need to define a, b, and c. To do that, we take our original expression. A equals to 1 because there's nothing in front of the quadratic term. You could imagine there's a 1 in front of it. B equals to -5 and C equals to 6. We use these values and plug them into the formula for the discriminant. Once we plug the values into the formula, we calculate -5 to the power of 2, which yields 25, minus 4 times 1 times 6 yields -24, and our discriminant is 1. Finally, let's verify our solutions. From before, we note that x equals 2 and the other x equals 3. For x equals 2, we have the following expression: 4 minus 10 plus 6 equals 0. This perfectly checks out, therefore this part is true. For x equals 3, we have 9 minus 15 plus 6, which also perfectly checks out, means both are correct. To summarize, all statements are correct. The equation factors to x minus 2 times x minus 3. The solutions are x equals 2 and x equals 3. And finally, the discriminant is indeed 1. In this exercise, we are going to solve an equation involving a square root for the first time. This is important for our domain restrictions. As you know from the elementary algebra chapter, the radicand, the value below an even root, must not be negative. Let's check that in our domain considerations. Because this is a square root, the expression under it must be non-negative, which is equal to greater or equal to 0. We can just simplify this expression, moving 1 to the other side by calculating -1 from both sides, and we obtain x must be greater or equal to -1. There are a couple of ways how you could approach this problem. One method, for example, is to isolate the square root on one side by dividing 4 by x minus 1, which we did right here. But there's also another way, which is way faster than that. This is a potential integer solution, and here you can simply alternatively look for a solution by inspection after rewriting the equation in a polynomial form like that. We start with the original expression and test with a number of values for x. In this case, it's quite easy to see which number for x to take to obtain the solution 4. Let's test with x equals 3. We use 3 and plug it in for x in our initial equation. This one simplifies to the following: 2 times the square root of 4, which is also 2, and this yields 2 times 2 is 4. Perfect. Finally, we consider x equals to 3 and take it back to our initial domain restriction. X, which is 3, is greater or equal to -1. Yes, it is, and therefore x equals 3 is the correct solution. To summarize, we determined the domain, which is x is greater or equal to -1, and we found the solution set. The solution set only consists of one number and is x equals to 3, which is the one and only solution to this equation. Finally, it's your time to shine. This is an entrance exam-like task, and I encourage you to apply the knowledge you learned throughout this video on the entrance exam-like task and see how well you did. The solutions are here on our website. Next to that, you can find other practice tasks which help you to prepare for the BBE entrance exam. Thank you very much for sticking until the very end of this video. If you like this one, I am sure you would like this one or this one as well. See you in the next one. Goodbye.